Good day everyone. I and my team will discuss about the methods of collecting, organizing, and presenting data in elementary statistics and probability. Before we start, I just want to remind you the mission and vision of our school. So now we go on to our topic. Our objectives are, after completing this topic, students should be able to determine and identify what methods to be used in collecting data. Second, determine the methods of organizing and presenting data. Third, describe frequency distribution table. The fourth is recognize the difference between group data and ungroup data. The fifth is construct and interpret a histogram. Then construct a stem and leaf plot. And the last is use appropriate graphs to represent data.
Methods of collecting, organizing, and presenting data. Data can be defined as a collection of facts or information from which conclusions may be drawn. And also, data are characteristics or information, usually numeric, that are collected through observation. In data collection is the procedure of collecting, measuring, and analyzing accurate insights for research using standard validated techniques. A researcher can evaluate their hypothesis on the basis of collected data. In most cases, data collection is the primary and most important step for research. We have two types of data, the primary data and the secondary data. Primary data is the kind of data that is collected directly from the data source without going through any existing sources, and it is often reliable, authentic, and objective inasmuch as it was collected with the purpose of addressing a particular research problem. Secondary data is the data that has been collected in the past by someone else but much available for others to use and are usually easily accessible to researchers and individuals because they are mostly shared publicly. The difference between the primary data will be collected by questionnaires, surveys, observations, consumer trial, poll, whole tests, and focus groups, while secondary data will be collected by books, newspapers, internet, or CDs. As you can see, I have the example of primary data and the secondary data. The example I put in here is the poll that we gather from my dear classmates, and in the secondary example was gathered from the internet, wherein you can see the housing characteristics in the Philippines, or what we call the census, from year 2000 up to year 2015. As you can see in the example of secondary data, in the national census, data are collected by the government because I got it from the internet. But before it became a secondary data, it is also a primary data before, wherein they have a person who will give house to house just to make sure and interview every family that lives in. One more thing you need to know about primary and secondary data. Primary data is accurate compared to secondary data. Primary data is usually up to date because it collects data in real time and does not collect data from old sources. Primary data is very expensive compared to secondary data. Secondary data is easily accessible and less time compared to primary data. Secondary data is available on different platforms that can be accessed by the researcher. Primary and secondary data has also a similarity. Like what I said, secondary data was once primary data when it was newly collected by the first researcher. The content of the data collected does not change and therefore has the same content with the primary data. It doesn't matter if it was further visualized in the secondary form, the content does not change. A common example of secondary data are definitions, theorems, and postulates that were made years ago but still remains the same. Primary data and secondary data are both used in research and statistics. They can be used to carry out the same kind of research in these fields depending on data availability. This is because secondary data and primary data have the same content. The only difference is the method by which they are collected.
When does collecting data become objective, subjective, and used as existing records? Collecting data become objective method when objective data are observable and measurable, while subjective method when subjective data are collected from personal communications from individuals in the use of existing records commonly collected in internet or old files like in the government papers. In objective data, they include things like height, weight, or number of elements. They are usually collected through observations or direct measurements. For example of objective data, the height of BSE2B students, as you can see in the picture. In subjective data, this may be spoken or written, but can also take other forms. Example is the brand of cell phone used in online classes. Both objective and subjective data can be both qualitative and quantitative. For example, you can observe objective, a color change that is qualitative, and you can ask people to express their opinions on an issue that is subjective. Quantitative is the using a numerical scale. Both types have advantage and disadvantage. For example, subjective data can provide a much broader range of information because many things are simply unmeasurable. These include variables such as level of pain, where everyone has their own interpretation. Even using a scale of 1 to 10, which makes the data quantitative, does not mean that it will be directly comparable between individuals. However, subjective data also depend on people remembering and assessing things accurately. Subjective data are therefore likely to be more unreliable when people have to remember events from longer ago. Where possible, therefore, objective data are prepared, but there is a general understanding that sometimes only subjective data are available. And in the use of existing records, the data means less efforts in data collections. Maybe inexpensive if owner of data provides them a little no cost. Possible source of data are plentiful. The example is the population of the Philippines as of 2005 to 2020 from the record of Department of Health. Methods of organizing and presenting data. To make sense out of this data, you will have to organize and summarize them in some systematic fashion. The most basic methods for organizing data is to classify the observations into a frequency distributions. But before that, we need to know about the textual presentation and tabular presentation. Textual presentation is the data are presented in the form of text, phrases, or paragraphs. It is common among newspapers reports depicting specifically the silent or important findings. Example is the country puberty incidence among families as reported by the Philippines Statistic Authority or PSA. As you can see, the details that had been written is the form text and paragraphs. And the tabular presentation, this is more reliable and effective way of showing relationships or comparisons of data through the use of tables. It is applicable for large dataset. Example is the data last February 11, 2020, wherein the number of admitted cases and confirmed cases is some province in the Philippines. The data is present in tables.
Now we proceed in frequency distribution table. What is frequency distribution? A frequency distribution is a list or a table containing the values of a variable and the corresponding frequencies with which each value occurs. Why use frequency distribution? A frequency distribution is a way to summarize data. The distribution condenses the raw data into a more useful forms and allow for a quick visual interpretation of the data. Qualitative frequency distribution table. The non-overlapping categories of the variable are identified. Frequencies percentages of observations falling into the categories are computed. And the qualitative frequency distribution table is a list of all categories, names, or labels, and the number of elements that belong to each of the categories. Qualitative frequency distribution table can be categorized the five senses. Look at the example I provide. You can see the data of the rate of BSE students and how hard the subject of elementary statistics is. Now, we have the quantitative frequency distribution table, and it has two types, the ungrouped frequency distribution table and the grouped frequency distribution table. Let's first tackle about the ungrouped frequency distribution table. It means have not been summarized and it is constructed when there are only few observations or if the data set contains only few possible values. And it is also called raw data. Raw data typically refers to a tables of data where each row contains an observation and each column represents a variable that describes some property of each observations. And in short, the ungrouped frequency distribution table shows data in randomly positioned and has no class interval shows. Now we need to know how to find the mean, median, mode, and range of ungrouped frequency distribution table. I've made an example that I gathered to the BSE Math students. As you can see, the table shows the final grade of BSE Math randomly. Now we need to know first the mean. Mean is equal to the sum of all given data divided by the number of all data. As you can see, we add all the data given divided by 20 and the mean is equals to 87.55. In finding the median, median is equal to the middle observations of all variables. Or, if there's no middle, get the sum of two variables at the center divided by 2. But before getting it, we need to arrange it from lowest to highest, as you can see in the table. Because we don't have exactly middle variable, we get the two numbers at the center and divided it by 2. Our median is equals to 87. Mode, the value that appears most often. Look at the picture. You can see that 87 has the most number that appears. So that our mode is 87. Range is equals to the highest value minus lowest value. The number with circle is the lowest and the highest. So we need to subtract it both. So our range is equals to 13. And now we go on to the group frequency distribution table. It is have been organized and it is constructed when there is a large number of observations and when the data set involves many possible values, wherein a class is one of the categories into which data can be classified. Class interval for a frequency distribution is obtained by subtracting the lower limit of a class from the lower limit of the next class, or subtracting the higher limit of a class from the higher limit of the next class. Class limits represent the smallest and largest data values that can be included in a class. The class boundaries are used to separate the classes so that there is no gap in frequency distribution. So our example is the table show the weight of the every students of BSE Math. Now we also need to know how to find the mean, median, and mode of the group frequency distribution table. In this example, you need to know first how to get the midpoint to know the median. Midpoint is equals to the lowest value plus the highest value divided by 2. So after getting this, we need to get the frequency times the midpoint. Now we can proceed to the mean of this data. Mean is equals to the summation of the frequency times the midpoint of all the summations of the frequency. And now we get the value of mean is equals to 56.975. Now we need to get the median. Median is equal to the lower boundary of median class or lower boundary sub MC plus the quantity of the one half of the total frequency or summation of frequency minus the cumulative frequency of the lower class divided by the frequency of the median class times the class width. To find the value of lower boundary of the median class, the median class is with the smallest cumulative frequency greater than or equal to the one half of the total frequency. So now we get the value of the lower boundary class of the median class is 50 minus 0.5 and it is equals to 49.5. And then the 1/2 of the total frequency is equals to 10. Then our cumulative frequency of the lower class next to the median class is equal to 5. And last, the class width is equal to the sum of the consecutive lower boundary, and it is equals to 10. Now our median is 49.5 plus the quantity of 10 minus 5 divided by 5 times 10 is equal to 59.5. Now we proceed to the mode. Mode is equal to the lower boundary of the model class plus the quantity of d sub 1 divided by d sub 1 plus d sub 2 times the class width. As you can see in the table, d sub 1 the highest quantity of frequency minus the frequency of the lower class, and the d sub 2 is the highest quantity of the frequency minus the frequency of the next upper class. Now we need to get the value of the mode. Mode is 49.5 plus the quantity of 4 divided by 4 plus 6 times 10, and it is equal to 53.5. Now we have the steps in construction of group frequency distribution table. These are the steps. First, identify the largest data value or the maximum and the smallest data value or the minimum from the dataset and compute the range. So the range is the difference between the largest data and smallest data. Number 2, determine the number of classes K using, where N is the number of observations in the data set. Round off K to the nearest whole number. It should be noted that a computed K might not be equal to the actual number of classes constructed in an frequency distribution table. So, number 3, calculate the class size using C, or C is equals to the range over K. Round off C to the nearest value with precision the same as with the raw data. Number 4, construct the classes or the class intervals. A class interval is defined by a lower limit and an upper limit. The lower limit of the lowest class is usually the minimum of the dataset. The lower limits of the succeeding classes are then obtained by adding C to the lower limit of the preceding classes. The upper limit of the lowest class is obtained by subtracting 1 unit of measure, where x is the maximum number of decimal places observed from the raw data. From the lower limit of the next class, the upper limit of the succeeding classes are then obtained by adding C to the upper limit of the preceding classes. The lowest class should contain the minimum, while the highest class should contain the maximum. The fifth is the tally the data into the classes constructed in step 4 to obtain the frequency of each classes. Each observation must fall in one and only one class. And the sixth is add distributional characteristics. Now I have an example number 1 that we will use to show the steps in construction of group frequency distribution table, wherein Professor EJB is the professor of the Department of the Secondary Education and wishes to determine the amount of studying BSc major in math students do. He selects a random sample of 20 students and determine the number of hours studies each student studies per week. Let me show you the steps. Identify the largest data value, or range is equals to the maximum minus minimum. So our range is equals to 62.2 minus 25.5. Our range is 36.7. So number 2, determine the number of classes where n is the total number of observations in the dataset. Number of classes is equals to the square root of total number of observations, where k is equals to square root of 20, or it is equals to 4.47. So we need to round off in nearest whole number the number of classes. So it is equals to 4. Calculate the class size, or C, using the C is equals to the range over the number of classes. So class size is equals to 36.7 over 4, and it is equals to 9.175, and we need to round off nearly. So our class size is equals to 9. Construct the classes or the class intervals, wherein I is equals to the highest value minus lowest value divided by the number of classes. So I is equals to 62.2 minus 25.5 over 20. So our intervals is equals to 1.835. So we need to round off it. So our class intervals is equals to 2. So tally the data into the classes constructed. The table shows the tally of the said example number 1, as you can see in our example. 5 distributional characteristics of the data in frequency distribution table. First is the true class boundaries. The true class boundaries reflects the continuous property of the continuous data. It is defined by a lower true class boundaries and an upper true class boundaries. These are obtained by taking the midpoints of the gaps between classes or by using the following formulas. Lower true class boundaries is equals to the lower limit minus 0.5 or 1 unit of measure, and the upper true class boundaries is equals to upper limit plus 0.5 or 1 unit of measure, wherein lower limit or LL is the lower limit and the UL is also called upper limit. This table came from the data of example number 1. As you can see in the table, it shows the red circle, the lower limit and the upper limit. The table shows the true class boundaries, wherein the lower true class boundaries is equals to the lower limit minus 0.5, and the UTCB is equals to upper limit plus 0.5. The second is the class mark or CM. The class mark is the midpoint of the class and is obtained by taking the average of the lower and upper true class boundaries, or CM or class mark is equals to lower true class boundaries plus upper true class boundaries divided by 2. Now look at the example number 1. Table is class mark. As what I said, class mark is equals to the sum of the lower true class boundaries and the upper true class boundaries divided by 2. So our class mark are 29, 38, 47, 57, and 65. The third is the relative frequency or RF. The relative frequency refers to the frequency of the class as a fraction of the total frequency, wherein the formula is relative frequency is equals to frequency divided by the total number of frequency. RF can be computed for both qualitative and quantitative data. RF can also be expressed in percent. This table shows the relative frequency of example number 1. So RF is equals to the frequency divided by the total number of frequency. The fourth is the cumulative frequency or the CF. The CF refers to the total number of observations greater than or equal to the lower limit of the class, or the total number of observations less than or equal to the upper limit of the class. The table shows how to get the cumulative frequency, wherein the first row just copy the frequency and put it on the cumulative frequency. And then the next row will be the sum of the frequency and the cumulative frequency that they're following, or first to them. What I mean is, if the first row is 7, then add 3 to make 10, and write it on the next row of the cumulative frequency. And then 10 plus 5 is equals to 15, and so on and so forth, up to the last row. Our fifth is the relative cumulative frequency, or the RCF. Relative cumulative frequency refers to the fraction of the total number of observations greater than or equal to the lower limit of the class, or the fraction of the total number of observations less than or equal to the upper limit of the class. Both the less than relative cumulative frequency and greater than relative cumulative frequency can also be expressed in percent. The table shows how to get the relative cumulative frequency, wherein it is equals to the cumulative frequency divided by the total number of frequency and then express it in percent.
Graphic presentation of data. What is graphical presentation? A graphical representation is a visual display of data and statistical results. It is more often and effective than presenting data in tabular form. There are different types of graphical representation, and which is used depends on the nature of the data and the nature of the statistical results. Graphical representation is the visual display of data using plots and charts. It is used in many academic and professional disciplines, but most widely in the field of mathematics, medicine, and science. Graphical representation helps to quantify, sort, and present data in a method that is understandable to a large variety of audience. Graphs enable us in studying the cause and effect relationship between two variables. Graphs helps to measure the extent of change in one variable when another variable changes by a certain amount. Graphs also enable us in studying both time series and frequency distribution, as they give clear account and precise picture of problem. Graphs are also easy to understand and eye-catching. We have types of graphical presentation. As you can see, the ungrouped and grouped data, wherein the ungrouped data is composed of line graph, bar graph, and pie graph, or circle graph. While in group data, the frequency polygon, cumulative frequency distribution, or ogive, and the histogram. Let's talk about the first ungrouped data. Line graph. Line graphs are simple mathematical graphs that are drawn on the graph paper or plotting the data, reconnecting one variable in the horizontal x-axis and the variable of data on the vertical y-axis. In this, you can see an example is the time where the number of people who buy in the market. This is the line graph style is. What is bar graph? It is a data represented by bars. The bars can be made in any direction. vertical or horizontal. The bars are taken of equal weight and start from the common horizontal or vertical line, and their length indicates the corresponding values of statistical data. When do we use bar graph or bar diagram? When the data are given in whole numbers, when the data are to be compared easily. This is also the sample for bar graph, where you can see also the time wherein the number of people who buy in the market. What is pie diagram? It is a circle in which different components are represented through the sections or portions of a circle. To draw a pie diagram, first the value of each category is expressed as a percentage of the total, and the angle 360 degree is divided in the same percentages. Then at the center of the circle, these angles are drawn simultaneously, starting from the particular radius. In this way, we get a set of sectorial areas proportional to the values of items. Now, we proceed to group data. Histogram. The histogram is used to show the differences in frequencies or percentages among categories of an interval ratio variable. In our example, like what you see now, the categories are displayed as continuous bars with width proportional to the width of the category, and the height proportional to the frequency or percentage of that category. A histogram looks very similar to bar chart, except the bars are contiguous to each other and may not be equal with width. In a bar chart, the spaces between the bar visually indicated that the categories are separate. When do we use or present histogram? When the data are given in the form of frequencies, when class interval has been displayed by a diagram, and when we need to calculate the mode of distribution graphically. What is frequency polygon? A frequency polygon is essentially a line graph. We can get it from a histogram if the midpoints of the upper bases of the rectangles are connected by straight lines. But it is not essential to plot a histogram. First, to draw it, we can construct it directly from a given frequency distribution. The example shows that the frequency polygon style is. When do we use frequency polygon? When data are given the form of frequencies, when two or more groups have to be displayed in one diagram, and when two or more groups are to be compared. What is cumulative frequency distribution? A cumulative frequency distribution is used to determine how many or what proportion of the data values are below or above a certain value. A cumulative frequency distribution is the sum of the class and all classes below it in a frequency distribution. All the mean is your adding up a value and all the values that came before it. Before we plot our data in cumulative frequency, we need to first get the less than and greater than cumulative frequency. And now, after we getting this value, we will plot the data as you can see in the picture. Stem and leaf plot. Stem and leaf plot is a statistical technique for displaying a set of data. Each numerical value is divided into two parts. The leading digits became the stem and the trailing digits became the leaf. The picture shows what is the stem and leaf in the dataset. Note that an advantage of the stem and leaf display over a frequency distribution is we do not lose an identify of each observation.